Okay.
Yeah?
Yep.
Okay.
Fine. Okay. Welcome, everyone. Hope you had a good lunch. Just before we begin, this session was actually labeled as a level 400 session, which is actually a mistake. It's actually a level 300 session. So if everyone's okay with that, I mean, if you want to leave now, you can do. Otherwise, you will be locked in. Good. Excellent. Okay. So let's start. I'm Manpreet. I'm from Datacom here in Auckland, just down the road. I work as a BI consultant. And this is Robert here, who will introduce himself.
Yes, hi. I'm a colleague of Manny's, also working for Datacom. Been in the BI data warehouse sphere for over 15 years. And yeah, we'll be presenting to you today.
Yep, excellent. So today we're going to be talking about PowerView and DAX on OLAP. This is a recent change introduced by Microsoft. So around about May, there was a cumulative update 4 that was released, which meant that DAX can now be natively supported against multidimensional models. And what that means is you get tools such as PowerView, which can now be used directly on your existing cubes, which is quite a nice thing to have for end users. So on the agenda today, first of all, we're just going to touch on the evolution to self-service BI. So, what is BI, self-service BI, how we've got from, say, relational models to our existing multi-dimensional models. We'll then move on to actually discuss the changed with DAX multidimensional in more detail, to show what it is and how it impacts possibly you or your end users. And then we're going to have some fantastic demos for you. So evolution to self-service BI. Now, what is self-service BI? Many people have different opinions of what it is, but from our point of view, it's really empowering the end users to be able to view their data when they want and how they want. And by how they want, I'm talking about what they want to see in tables, graphs, or however they want to see it, and quickly. So if they want to see it now, they get their data back now. So we go back to the days of relational models and relational databases. This is pre-OLAP cubes. Is anyone here remember those days when cubes weren't available? Yeah? Good. You're older than I am. So relational models, I mean, they serve a purpose and they work well. They're still existing today. I mean, we all use them. And SQL itself, SQL tables are very simple in structure. You have tables which have columns and rows. And here's just a very simple example of how you use that to query SQL table. The problem was, back in the day before we had self-service BI, the end user wasn't really familiar with SQL, so they couldn't really do their querying by themselves. They had to send it off to IT, who would then get back to them. Their requirements were changed, they then send it off again, another request. Not ideal. Level of self-service BI, non-existent. Also, a problem with relational models is as the volume of data grows, the performance degrades. So you can have complex querying over several different tables, and your response time can be pretty slow. And for self-service BI, you need something that's pretty much instant, and this was not the way forward. So the solution to the problem was OLAP cubes. Now, back in 1997, Microsoft purchased Panorama Systems, their OLAP business. And then 2 years later, in 1998, OLAP services was released as part of SQL Server 7. Anyone here remember those days when that was released? One person over there? Okay. I was actually at university when this was released, so I don't remember. So what are cubes, and why do we use them, and what's this got to do with self-service BI? Cubes, as you can see, immediately the structure is different. There is no concept of rows or columns. We have cells. And within these cells exist numerical values which we know as measures. Now, the measures by themselves are great, but they don't really give the end user what they want. So let's say we have a measure of total revenue of 10 million. If the end user is browsing the cube and that's the only value they see, yeah, they know they've got 10 million revenue, but what does that mean to them? They don't know over what time period, what products, etc. And this is where dimensions come in. And dimensions allow the user to slice and dice their data as they want. And dimensions also have hierarchies in them. Now, a typical example of a dimension is a time dimension, which I'm pretty sure everyone who's worked with OLAP cubes has used and built. So time dimension, if we were to apply that time dimension now to this 10 million revenue, now the end user can see the revenue broken down by year, which immediately gives them more value. The user can also then apply a product dimension or region dimension and start slicing and dicing that data as they see fit. Now, why a cube? So we could possibly do that in SQL. You can write queries to do that, but the beauty of cubes is that cubes hold pre-processed aggregate data. So what do we mean by that? So all those values that are in the cube have been processed and stored within a cell somewhere. So if it's at a year level, it's been stored. If it's at a month level, it's been stored. What this means is this enables the user to quickly and very, very easily interrogate the cube and bring back the data that they want, which is fantastic. The users normally use an interface of some sort to interrogate the cubes. But behind that interface, you need something else to be able to query the cube, and that's where MDX comes in. I'm just going to touch very, very lightly on MDX here because this is not an MDX presentation. I'm pretty sure you're all experts at MDX, as we all are. So MDX, what is MDX? Multi-dimensional expression language. It was released in 1997, so shortly after Microsoft bought the Panorama OLAP business. It was released as part of the OLEDB for OLAP specification. And it was really used for them to be able to let other products or their products and other products be able to query cubes easily. And it's become so successful that MDX is now the industry standard for querying OLAP cubes. And for those of you who are not familiar with MDX, you've got to bear one thing in mind. It's not like SQL where you can insert and update, etc. It's purely a data reading language. So the very basic concepts of MDX are unique names, tuples or tuples, depending on which part of the world you're from, and sets. And here we have just an example of each. So unique name, each object within the cube has to have a unique name. The reason because is when you send off your MDX query, it goes through all the objects, and as soon as it finds the object that matches your name, it's going to pull it back. So if you don't have unique names, you could run into problems. And here just have a very, very simple example of the unique name of mountain bikes in this really small database, which some of you may have heard of called AdventureWorks. And we just got a sales value next to it. Now, tuple. Now, a tuple allows you to use MDX to be able to go and grab your data and say this is what data I want. So let's say we've got two dimensions, a time dimension and a product dimension. At the point those two dimensions intersect in your cube, it will then grab the value from that point in the cell and bring it back. So you can think of it as a coordinate. So you're querying a coordinate. You're saying this is the coordinate I want my value back from. Again, here's an example of a tuple of mountain bikes by year. And sets are very simple. They're just a collection of tuples. Again, another example here, just two tuples we've had. Now, if you were to write SQL to bring back this query, so mountain bike, road bikes over 2 different years, you'd be writing a lot more code than this. And the fact that all these the values are pre-processed and they're stored in the cube means the response time is extremely quick. Before we move on, let's just have a quick comparison between SQL and MDX. You can see some similarities there. You can see a select, from, where clause, etc. But in the SQL, you can see that it's joining between different tables. It's also having to do the aggregation as part of the query. MDX, don't need to do aggregation because it's already done for you in the cube, so it's just going away and grabbing the value. The one thing between MDX and SQL, for software, it's a lot easier for them to generate MDX in the background rather than SQL. If you change your query in SQL, you have to go around changing joins and aggregations, whereas MDX is far easier to be able to generate. So what I'll do now is pass you over to Robert, who will now talk you over to the next level of self-BI, which is DAX query language.
Thank you, Manny. Well, after MDX, Microsoft went back and said, well, you know, we're listening to the community, and the business users are still struggling a little bit with all this query language, finding it a bit difficult to understand the models. What can we do about that? You know, we're trying to move towards a self-service BI, and users are still struggling trying to extract the data out of the cubes and doing multidimensional queries. So they came up with DAX, next step in self-service BI, another layer of abstraction, making it easier for the users to be able to write functions to analyze their data. It is a language specifically designed for users, business users. It is closely related to Excel. It is about defining formulas. So business users who are very familiar with defining formulas will find themselves back in this language. They can see how they can potentially use this. So let's look at the query syntax. Again, let's go back to T-SQL. Here we've got a simple query statement where we get the total sales, average unit price from a fact table, joined on a dimension, and grouped by calendar quarter. So what does that look like in MDX? And we have the query there on the right-hand side. And we still see certain similarities between T-SQL and MDX. We're still talking about a select, we're still talking about a from. Granted, we don't have to do the joins anymore, but still. So what does that look like in DAX? Completely different. We're talking about evaluate, we're talking about summarize. There is no joins anymore, there are no select statements. These are functions that a business user is more familiar with, especially those who have used Excel. Summarize means group. We're defining what dimensions we're pulling the data from, what we're slicing by, which is date. We identify labels for the summary functions, total sales, which is the total internet sales amount, and average unit price, and we give a label of average unit price to that. Something that a business user can easily relate to and work with. SQL 2012, when they introduced Analysis Services 2012, they also introduced a tabular model. And with that, the introduction of DAX. Up until that point, all we could do in terms of accessing the multidimensional models was use MDX. We had no ability to use DAX on multidimensional models, only on the tabular model. Now the tabular model, as some of you may know, and those who don't, it's a in-memory based table. It is relational in background, and it's quite fast because it's all in memory. The tabular model, as I mentioned, can only be accessed via DAX. Now, they also introduced PowerView, new visualization tool, which is part of SharePoint and Excel. Great tool for users to be able to quickly grab data and create some dashboards and some reports. In the background, it generates DAX, and that's on the tabular models. So, the old architecture, what did that look like? As mentioned, with PowerView, we can only access tabular models via DAX. In performance point dashboards, we could use MDX on tabular as well as OLAP. What does it look like now? With the introduction of Cumulative Update 4, which was released in May 2013, and the SQL 2014 CTP, we now have the ability to use DAX directly on multidimensional models. This allows us to leverage our current investments in data warehousing projects. What does that mean in terms of the cubes? A lot of people say, oh, well, DAX will probably be translated to MDX and then passed on to the storage engine. No. DAX is fully supported within the formula engine. It will generate its own query plan and forward that on to the storage engine. In order to be able to provide that abstraction, and because DAX was originally designed for tabular models, there needs a translation that needs to take place, and this is done in the background. And basically, if we look on one side, we've got our multidimensional objects. On the other side, we have our tabular objects. The cube equates to a model. Cube dimension to table, attribute keys and names to columns, measure group to table. And from there on, it's pretty much the same. But in the background, DAX needs this translation in order to work. Manny will show later on how that is actually done. Right. Demo time.
Yay.
Manny.
Okay. So we're going to split the demo into two parts. The first part is going to be PowerView and OLAP, to show you how your features in cubes, how they behave in PowerView. Is anyone here actually used PowerView against OLAP? Anyone? One person, excellent. Anyone use PowerView? Yeah, okay, great. Okay, so let's get cracking. Firstly, apologies for the look. Our resolution was changed on the laptop and it's kind of messed up our VM. We'll get cracking anyway. So before you create a PowerView report, you have to set up a new connection. So what you do, go to Data Connections, and this is in SharePoint, by the way. Let that run. Go to Files, and then New Document, and you'll see Report Data Source there. What I'll do is, rather than creating a new one, I'll just edit an existing one just to show you the content. So if we go down. SharePoint's a bit sluggish after lunch, you see. Okay, so here's the content of the connections. So first thing, the data source type. You have to select the Microsoft BI Semantic Model for PowerView. If you don't, you'll quickly find out because it will error. But yeah, you do need to select this option. In your connection string, it's quite important to add the cube as part of the connection string. Now, I know most of us, when we create connection strings, we don't add the cube. It's just habit. You need to do this, especially if you have more than one cube within your database. Otherwise, again, it will error. But it's good practice to do it anyway. So let's say you only have one cube. It's good practice to have that because it prevents future problems. So you just remember to put your cube name in there. You pop in your credentials. In this case, I've had to store my credentials because we haven't got internet access. But you can do Windows authentication. And then, obviously, you need to enable the data source. So let's go and see now PowerView itself. Once it's cancelled. Okay. So all you do is you select your connection string or your connection, and that will fire up PowerView. It's going there. Excellent. So here we have PowerView. Now just quickly go through the field list. So I'll expand that. Let's zoom in. Here we have your measures. So these are all coming from the cube directly, and they're being shown, represented here as you would expect them to be seen. So we have our measures here, and then we also have our dimensions, again being represented as tables. Now within our measures, PowerView also shows your display folders. When you set up display folders in your cube, they're shown in PowerView. If we drill down, PowerView also recognizes stuff like KPIs. So here we've got a little traffic light icon next to revenue, which indicates that all these measures are KPI values. If we show you just an example of a dimension. So here we have a geography dimension, and within our cube, it's the geography dimension, the attributes have been specified as geographic locations, so country, city, etc. PowerView recognizes that by putting a little globe next to it. What that means is you can just use these as part of a map if you want to have maps within your PowerView reports. The maps are Bing maps. Fortunately, I can't really show you right now because I haven't got internet connection. And you'll see everything else is pretty much the same. So if we go just to show you your hierarchy, again, your hierarchies are represented as you would expect to see them. So here we go. So we have a product categories hierarchy, and again, it shows it as you expect it. Now, some of you who have used PowerView probably looking and thinking, you know, I've seen this, it's nothing new. But you've got to remember this is coming directly from the cube. So whatever's in your cube, whatever structure you have in your cube, it's here in PowerView. So as Robert mentioned, in order to get PowerView to be able to work, you've got to have a way of getting the multidimensional objects and mapping them into tabular metadata. PowerView does that by using a dynamic management view. What this view does is it exposes those multidimensional objects as tabular metadata. And what I'll do, I'll just quickly show you in Analysis Services that query itself. So it's just select star, and we've got this system discover CSDL metadata. That's the name of the view. And you can run this against your multidimensional cube, which I'll do now. And the result set is an XML schema. And it's not very, sorry, give me more bit. You can't really read that in Management Studio unless you're superhuman. So what I've done is I've just copied and pasted that into an XML file and opened it up in Internet Explorer just to give you an idea of the type of metadata that's produced from that view. So PowerView takes that metadata, constructs your field list and your measures, your dimensions, and it also uses that to generate the appropriate DAX queries when it's actually trying to go back and get your information from your cube. So let's just show you a few examples of PowerView in action. So what I'll do now is I'll just build you a very, very simple report just to show you how easy it is and the performance of PowerView when you're actually querying cubes. So what I'll do first, I'll just grab some data, so put country in there. It will work. And we'll also put state, and we'll chuck in city in there as well. Now what we do with these, I will enlarge these, unless everyone's happy with very small letters. So just enlarge those. Click on Slicer, and I'll show you what Slicer does in a moment. Slicer, Slicer. What's that? Might be a bit difficult to view everything here because of the resolution, but I'll do my best. So these are just simple slices that we're grabbing from our geography dimension. Okay, this doesn't want to go down. Now, it may appear in your PowerView report that these are three independent tables or objects, but they actually still maintain that relationship with one another. So if in the country we set Australia, it filters out the other two slices. And it's not just a top-down approach, so you can go all the way down to city, sector city, and again, it will just filter out the other two slices. So let's get some data in there. So what we do, we just grab date. Let's grab fiscal year, and we'll grab product. Let's grab product category, and then we'll grab a couple of measures. So we do reseller sales, and we'll get sales amount, and we'll get gross profit. Now, gross profit in the cube is a calculated measure. So for the end user, it looks no different. For them, it's just a measure. Let's just increase the size of that. Is that way? Increase that. And what we'll do is, our table by itself is pretty boring, so let's grab the fiscal year again and put some measures against it. Do sales amount and profit again. A good thing about PowerView is, as with all good self-service BI tools, is we can change the table to a chart. It does it quite easily. So we've got a chart here, let me just expand that for you. If I can see where it's quite difficult to see on a laptop. Okay, cool. So we have a nice chart there, table, slices, which we can use, which then go away and filter the table and the graph. Very simple, very easy to do. We also have this filter pane here, which I will show you what that does. That's just you can apply if you want to apply additional filters. You don't want to have slices in there. You can apply additional filters if you want. So we'll just stick a filter in there just to show you. Type business. So here, if you can see that clearly, just type of businesses, and let's say we want to do specialty bike shops. Again, it just filters the table and the chart. So you can see it's very easy and very quick. And again, this is coming directly from the cube, so there's no conversion to MDX anywhere. This is PowerView sending DAX directly to the multidimensional model and bringing the data back. Now, if you've got your existing cubes there, I mean, this is a great little tool for the end users to quickly be able to create reports or dashboards. As you can see, it's very simple, dragging and dropping. There's no emphasis on the user to actually write any DAX queries. It's all done using the interface. So what I'll do now is to show you how some of the cube features, how they behave in PowerView. So what we'll do is just create a new view. And we'll get in, let's get date in again. We'll get fiscal year. I will enlarge that. And what we'll do this time is I'll show you KPIs, yes. So let's do sales summary, and we'll go to revenue. We'll pop those all in there. I'll enlarge that in a second. A bit too big. So as you can see, again, these KPIs are built within the cube, and PowerView handles them easily. So this is just a very simple KPI, just to show you revenues and goals and the trends. So again, you've got your KPIs in your cubes. Your end users can now access them really easily, which is great. So let's do another view. So just show you a couple more things. And we'll show you favorite. So I've worked with plenty of cubes in the past, and sometimes when you're using other vendor products and you're on top of your cube, you see some features don't always behave as you want them to. A good example is parent-child hierarchies. Has anyone here ever had issues with parent-child hierarchies? Yeah. It can be quite a pain to fix, but PowerView handles them perfectly. What it does is actually flattens your hierarchy out. So as you can see in the list here, so this is the employees, this is the parent-child hierarchy. It's just flattened those out, all the levels out, so you can see them all. And what we'll do, I'll just select them all, so they come into the view. And I'll put a measure next to them, just to show you how that looks. So let's do sales target, or sales amount, yeah. Let's enlarge that. It's really quite difficult to see the table. How do I enlarge that? All right, is that okay? Yeah, okay. Now that's not really ideal. I mean, it's flattened everything out. I mean, you don't want to present this to anyone. But nice thing with PowerView, you can just switch the table into a matrix. And what that will do now, that will just tidy up, and now it's a lot more presentable. So your parent-child hierarchy, existing parent-child hierarchies are easily usable within PowerView. So let's get out of it. So next thing, I just want to show you another feature is default members. Everyone here know what default members are in cubes? Yeah? Okay, see a few nodding heads. Do you want to come up and explain it? No. Okay, I'll do that. So default members, so when you set up a new dimension in a cube, you assign it a default member. Typically the default member is the all member. What that means is when you query a cube, so select, you put 2 dimensions in there and your cube's got 10 dimensions. Because you've got a default member of all, it automatically assumes that you want the all member, so you just go and grab that value. With default members, you can actually assign a different default member. So let's say your end users only interested in querying data from New Zealand only. So for your country dimension, you can set up a default member for New Zealand. What that means is they don't have to apply that dimension every single time. It will just automatically be applied in the background. So here's an example. It's a very, very simple cube I've set up with a default member. And I'll just show you how that behaves in PowerView. So let's go to order date in there. And we'll get sales amount. I'll extend that, just enlarge it so you can see. So as you can see, we've got 2,000, it's only 3 years worth of values there, and a value of just under 11 million. Now to show you that there is a default member, what we'll do is just grab the sales territory group, pop into the filter pane, enlarge that, zoom it. Can everyone see that? Yeah, just about. So I've set this default to Europe because I'm from Europe, and that's what I've chosen. So it's automatically applying that to the results. So to override that, if we select the all, now it brings back everything. So you can see it's got 2005, 2006, 2007, and the value shot up. So your default members, your existing default members in your cube work, and they work as expected in PowerView. And the last thing I will show you in PowerView is calculated members. So we all use calculated members within cubes. A typical example of a calculated member is a time utility dimension. And what that can allow you to do is set up a dimension, put some MDX scripting in your cube, which then you can use to say if you want to get year-to-date sales, or this year, last year sales, or last period sales, etc. You can code that in and apply that when you're browsing the cube. So here I've got a very simple calculated member to date calculations. And what I'll do, I'll just pop that into there. Let's see if I can just turn that around. And what about date? So it's very simple. All this does is looks at the previous period and brings back the value. And this is just to demonstrate that your calculated members in your cubes will function as you expect them to do in PowerView. So that is PowerView. If I switch back.
That one, yeah.
Okay. It's PowerView for OLAP. So just a quick summary. So we looked at how PowerView works. We looked at the structure of it and just showed you how it actually goes and uses that DMV to actually construct the list, and it uses that to generate its DAX queries. Looked at KPIs. They work perfectly. Default members, parent-child hierarchies, calculate members and calculate managers. So most of the stuff that you have in your cubes will work in PowerView when you're using it directly on your cubes. And this is just a quick slide just to remind you how to connect to the cube. Just remember to add your cube in there because it can cause you problems. Now, Robert will do a very exciting demo of DAX queries in Management Studio.
Just a quick question.
Sure.
The parent-child hierarchy, it shows it flattened, right?
Yeah.
So it uses the level naming template available in the cube, or it gives its own level 1, level 2, level 3, level 4?
It does it part of the, so that dynamic management view that you use, that PowerView uses, within that it actually assigns the levels. So it uses that to grab it and label it. So if you were to actually run that view against AdventureWorks or whatever, you'll be able to see those levels.
Another question. Is there anything the cube developer needs to do to exploit this, or they don't change any of their practices?
No. So again, whatever the reason for this change is because it lets you actually leverage your existing cubes. So you don't need to do anything differently. So if you've got so when you set up your dimensions, you can choose a type for each attribute, and that's where you select in that, PowerView will pick it up and it will know that's a geographic location.
Okay, and there's a large photo in there as well. Photographs come through the cube?
Yeah, photos come through. So you can use images, you can use geographic maps, you can do pretty much all the stuff you can do in cubes.
But it requires a specific license of SharePoint?
You need SharePoint, yeah. This only works.
It's not just SharePoint, is it? Is it enterprise SharePoint?
What we are using currently is the enterprise version, yes. And that's, I think, is enterprise the only one that you can use?
Yes.
I think so, yes. Yeah. Cool. Okay. Robert?
Right. Okay. DAX. Now, we can pretty much run DAX queries in SSMS. And basically, all you need to do is open up your SSMS browser, go to your analysis services, and request an MDX query. Now, bear in mind that this is a cumulative update, and there's a CTP 2014. So I'm assuming at some stage, we'll probably see analysis services MDX/DAX. So even though it says MDX query, don't worry, you can still type your DAX queries inside SSMS, and they will run. Bear in mind, however, that there are still some quirks in there. Sometimes it will underline particular commands because it doesn't seem to recognize them. but I'm sure that will be fixed up in future releases. Now, as we can see here, these are the 3 examples I showed you earlier between TSQL, MDX, and DAX. So just to refresh your memory a little bit there. Now, as I mentioned, it's about defining measures and defining formulas and using them in a summarize statement, evaluate statement. How does that work? Well, it's pretty straightforward. Basically, I use a define function and create a measure. I create a measure based on a particular structure. And in this case, what I've said is, look, grab me the internet sales amount minus the total product cost, and do that, slice that by date. I then use this in my evaluate statement as an added column. So I'm still asking the query to slice and dice by date and add the additional measure, calculated measure, sales amount average. Now, it doesn't make a lot of sense. I mean, I said here internet total product cost, so this should actually be profit. But okay, hey. If I run that, bang, I get my result set back. Just checking back here to make sure if that's visible enough for everyone.
Yep.
Yeah? Okay, so pretty straightforward. Okay, now, as we mentioned earlier, there's a lot of mapping that goes on behind the scenes with DAX. It translates the tabular structure into a multidimensional structure. Now, what does that mean? In essence, that means that what we need to ensure is that we have the correct composite keys. Some of these keys are visible, others are not. So it can be quite simple to have a evaluate instruction using one attribute, and you will get your result set back. But if you've got multiple keys, it's not going to work. It'll complain. So if I run this, I'll get an error message back. It says calendar quarter is part of a composite key. Please provide me with all the parts of that composite key. Now, that's a bit of a problem because, well, I can't really see what that composite key is. I don't have all that information here. So in that case, you would actually have to go back to that one XML query to see where that is. So if I look up calendar quarter here, where is it? There we go. We see we've got 2 keys. Calendar quarter key 0 and key 1. So what I need to do is I need to ensure that both those are inside my query statement. So I introduce those here. I run my query, and I get my result set back. Now, that's given me the keys. It hasn't given me the actual value. So what I do now is I can also introduce calendar quarter as the value, and it will return that for me. So, in terms of the define function, I showed you how that works. Now, defining your measures, it can be embedded. So you can have a definition within a definition used by another definition. It can get quite complex. From that point of view, you could wind up with something that becomes quite large and unwieldy. So you really have to think about what you do.
I'm assuming there is no major gain in performance or anything at squaring a cube, like a multi-dimensional cube, with DAX versus MDX. So if you already have your queries of your code resonating with DX, you might as well stay there.
It's the next part I'll show you. Yeah? So now we come to the crux of it. The performance. Now, yes, you would say, okay, well, what benefits are there really for using DAX as opposed to using MDX? You can see the business benefit. I mean, the business users are probably more familiar with defining measures than they are with using MDX. But what's the performance gain, if any? Because it's another language. I mean, is the translation better? What does it equate to? So in the background, what I'll start running is Profiler. I'm sure most of you are familiar with Profiler. Now, I've already set up a template, DAX versus MDX, so we can see what particular events. Is that readable for everyone? Yeah, okay. Interestingly, we can actually look at the DAX query plan inside the Profiler. However, we cannot do that with MDX, so I can't actually show you any MDX query plan. So it's actually difficult to show the differences in how MDX operates opposed to DAX. But we've got a set of measures that we can set up in Profiler, have it run in the background, and use that for our performance measurements. Then again, we can also see how well it does by running the query itself here. So I thought, well, let's see if we can come up with an example. What is pretty demanding in terms of a query? Cross joins. I'm going to create a query that selects and slices over multiple dimensions. How will MDX handle that? How will DAX handle that? So if I got a simple one here, which is just one-dimensional, I run that. That's an MDX query. Bang, I get my result set back pretty much within the second. Okay, great. Now, what about 2 dimensions? I'm using customer, and I'm going across date dimension. Great, let's see what that does. This is MDX. Okay, this is taking a little bit longer. And it took about 7 seconds to return the result. And this is a pretty much straightforward query. I mean, give me the sales amount sliced across these dimensions. So what does that actually equate to in DAX? So let's go pull out DAX. I'll run the one-dimensional one. And really, not much difference, pretty much within a second. Okay, let's go across 2 dimensions. So remember, the previous one, MDX, took about 7 seconds to run. So how long does it take in DAX? Pretty much 3 seconds. Wow, that's huge.
Can I ask you to run your MDX one? Because obviously you've now cached a whole lot of data.
Yes, but even if it's cached, you see the difference? Yeah? So even if now what I'll do is I'll run one that goes across 4 dimensions, and some of that will be cached. It's going to take pretty much 11 to 12 seconds to run, yeah? And if I go and use 4 dimensions on DAX, it's still pretty much more efficient than MDX, yeah? Yes, it goes to the cache. If we go to the profiler, we can see that. So let me see if I can expand that and make it a little bit more readable. So behind the scenes, we'll see non-cache data for MDX being retrieved, and then for DAX, also non-cache data being retrieved. Yeah. So at least what we can see from a cross join on multiple dimensions, DAX seems to be far more efficient than MDX. Yeah.
How it's possible? It's need to read it and put in memory to return it. How it can be faster?
I'm not quite sure about the architecture behind it and how it exactly works. Yeah. I mean, it's still relatively new, but yeah, I wouldn't be able to answer you directly on that one. Yeah. Yeah, I'm not overly familiar with the storage engine behind it and how it builds up its query plans and then translates that back to retrieving the data. Yeah? Okay. Right. So, we looked at Management Studio.
So
Yes?
question?
Just wondering what version of SQL you're running, and are you running cumulative update or not?
Yes, we're running SQL 2014 on this one.
Yeah.
Yeah. And the fact table had 60,000 rows. So not a lot of rows, but still you can actually see the difference between the two results there between MDX and DAX. Yeah?
Is it the same in the 2012 cumulative update 4 or whatever?
Yes,
Yeah.
because I tested this as well at the office on 2012, and they are pretty much the same. Yeah. So another important point, and Manny pointed that out, when you actually connect, make sure that if you've got more than one cube in your database, specify the cube in your connection, because otherwise you will get an error. Yeah. So I looked at member keys. It's important to remember that some attributes are invisible, and if they are part of a composite key, you will need to specify that in order to get your result set out. Yeah. The other important part as well is remember that there is a translation that takes place between the tabular model to the multidimensional model, and that translation is done via that XML. And it's all done in the background. And when Manny was doing his demo in SharePoint, it was continuously consulting that XML to look at how things needed to be translated and to retrieve the data. Yeah, I talked about DAX measures, how you can define a measure and use that measure. It can be nested. One important thing to remember, you cannot write DAX directly into a cube. You can with MDX, but not with DAX. Yeah? One of the big differences between DAX and MDX, and it's a different way of thinking. When you write a DAX query, you think more about how do I filter the data in order to get what I want, and what aggregation function do I apply. Whereas with MDX, it's how do I slice, what axis am I looking at? So that's the big difference between the two. We looked at performance. Now these are measurements I took at the office on a different machine, but they are pretty much similar in terms of showing the performance leap on a cross join between MDX and DAX. So on multiple dimensions, DAX seems to outperform MDX.
Just some gotchas, just so you bear in mind. As I said before, PowerView does actually allow you to use pretty much all your features that you have in your cube. However, some do not work. Actions don't appear in PowerView yet. So actions in your cube can be opening up a URL or drilling into a report. Unfortunately, PowerView doesn't support that at the moment. Name sets, again, are not supported in PowerView. You can't use name sets in DAX either. So when you're querying, if you're manually querying your queue in Management Studio, you can't use name sets in your DAX queries. Again, because we demonstrated PowerView from within SharePoint, there isn't the ability yet to be able to connect PowerView directly from Excel to your multidimensional cubes. Hopefully that will change sooner rather than later, but at the moment it is only via SharePoint.
Right, what does it all mean? Well, I think the biggest difference here is that Microsoft have listened to the community and have answered the question, well, you know, we want to maximize our current investment in multidimensional cubes. Can you please provide us with a DAX query language on top of those cubes? And they have. I think that's very important for the evolution into self-service BI. DAX is more easily understood by business users. And we saw in the demos how you could quickly create a measure, reuse that, and have embedded measures, something that the users are very familiar with. The question, of course, is, will developers use this? Well, I can't really use it in my cube, so I won't be using it from that perspective. You'll find that DAX will mainly be used in Excel together with Power Pivot tables, and My thinking is that what will happen is that generally the expert business users will do their analysis up front in Excel, use Power Pivot tables on top of multi-dimensional cubes, using DAX to do calculated measures, get the data out, create a dashboard, toy with the data to get an understanding of how that data fits together before creating a dashboard and flicking that over into production, either publishing it directly into SharePoint or by handing it over to IT and say, can you please publish this in a more formal process. It adds great flexibility for the BI semantic model layer. Yeah?
Yep. So just to finish up now, so just to remind you that if you want to be able to use PowerView on OLAP, you have to apply the cumulative update on SQL 2012, or you can just download and use 2014 CTP. You also need to upgrade the reporting services add-in for SharePoint. And again, it's only available via SharePoint at the moment. There's nothing, you can't really do direct querying from PowerView from within Excel. Related content. Guess everyone's looking forward to that. Closing drinks. Excellent. Because you're a great audience, the first round is on us. Yeah. If you've got any questions, feel free to grab you can ask them now. I think we might have a couple of minutes. Any questions?
Sorry, is the DAX converted to MDX when it hits the queue, or is it actually?
No,
No, it's native.
it's native.
So in the formula engine in analysis services, previously you can have MDX, DMX, and some SQL. Now you've got DAX in there as well, so it's natively supported. Yep. So, yep. No, this is at the moment it's only with SharePoint. Yeah. Any other questions? No? Excellent. Thank you for your time.
Yeah.